Have you ever wondered what it really takes for an AI, not just to see an image or read text, but to actually reason across all of it? Images, videos, text, and then create something new that genuinely makes sense in our world.
Yeah, it's a huge challenge.
For ages, it feels like proprietary systems, the big names like GPT-4o, Gemini, they've shown glimpses of these incredible multimodal skills.
Right, leaving the open source world feeling a bit behind.
Exactly. But what if there's a new open source model that's not just catching up, but actually showing us how these complex emergent reasoning abilities get unlocked?
So that's where this paper comes in.
Today, we're diving into ByteDance Seed's fascinating paper, Emerging Properties in Unified Multimodal Pretraining. We'll be unpacking their new model, Bagel.
Bagel. Not the food.
No, not the food. Our mission is to figure out how Bagel does what it does, what these emerging properties really are in AI terms, and what this might mean for the future of multimodal AI.
Okay, so for the quick version, that 1-minute summary. Bagel is basically a unified decoder-only model. Think of it like many LLMs today, focused on generating stuff from input.
Right, a foundational model.
Exactly. It's trained on, get this, trillions of tokens. And the data is super diverse: text, images, video, web data, all interleaved, mixed together.
Trillions, wow.
Yeah. And the key idea, the real insight, is that scaling up with this kind of rich, structured, interleaved data unlocks these emerging capabilities. We're talking complex multimodal reasoning.
Okay.
This lets Bagel seriously outperform other open source models, not just in understanding stuff, but in generating it too. And crucially, it can do advanced things: freeform image editing, predicting future video frames, 3D manipulation, even navigating virtual worlds. It shows a much deeper grasp of the world than we've typically seen in open source.
That really sets the stage. It's striking, like you said, that these advanced skills seemed locked away in proprietary models for so long. Why do you think that gap existed, and how does Bagel propose to bridge it?
Well, the paper makes a strong argument. It suggests the gap is mainly down to how models are trained. A lot of previous open source work, while good, mostly used image-text pairs.
Like a picture and its caption, separate things.
Exactly. But the proprietary giants, they seem to be using something richer, what the paper calls carefully structured multimodal interleaved data. And Bagel's core strategy is basically, let's do that too.
Okay, multimodal interleaved data. What does that mean in practice? Break that down a bit.
Sure. It's not just those simple pairs. Think about how information appears naturally, like on a web page or in a conversation. You have text, then maybe image, more text, maybe a short video clip, all woven together in sequence.
So it's integrated.
Right. Integrated sequences. This gives way more context, allows for more natural interactions between the modalities, and preserves that flow of information. The researchers argue this is absolutely key for the AI to build grounded world knowledge, because it mimics how we humans actually experience and learn about the world sequentially, with everything connected.
That makes a lot of sense. So it's not just more data, but the way the data is presented, the richness and the relationships within it, that's what turbocharges the learning.
Precisely.
I like the analogy of a child learning. They don't just stare at flashcards, right? That's like the image-text pairs.
Right. Limited context.
Instead, they experience a story, pictures, maybe sounds, actions, all flowing together. That gives them a much deeper contextual understanding. That seems to be the power of this interleaved data they're talking about.
That's a great way to put it. That's the core idea.
So it sounds like this interleaved data is the secret ingredient. But building a data set with trillions of tokens across all these types, text, image, video, web, that's just a massive job. How did they actually build Bagel to handle all that? And what kind of content are we talking about in those trillions of tokens?
Yeah, the scale is definitely impressive. They pulled together trillions of tokens from text, images, videos, and web data. A key thing they focused on was video.
Why video specifically?
Because video inherently contains, as the paper puts it, pixel-level, conceptual, temporal, and physical continuity. Think about it. Things move smoothly, concepts unfold over time. This is gold for teaching tasks like image editing, navigation, or understanding 3D space.
Okay, makes sense. Where did they get it?
They used publicly available online videos, but also specifically included 2 open-source datasets: Koala 3D6M, which is rich in instructions and interactions, and MVIMGNet 2.0, which provides multi-view spatial understanding, seeing objects from different angles.
Gotcha. And beyond video, you mentioned web data.
Right. Web data was crucial for capturing complex, real-world, multimodal structures. Think about a typical web page, text, images, layout, all conveying meaning together.
Yeah, absolutely.
They use OmniCorpus, which is based on Common Crawl, so massive scale there. Plus, they added existing open-source image editing datasets to teach those fine-grained manipulation skills.
But web data can be messy, right? How did they ensure quality?
Good question. They used a two-stage filtering process. First, an LLM helped select relevant topics. Then they applied rule-based filters.
Like what kind of rules?
Things like removing user interface elements, checking image resolution, clarity, making sure there wasn't too much or too little text relative to images, checking relevance, trimming long documents. They even aimed for a sweet spot of 3 to 8 images per document.
Why 3 to 8?
To give balanced context. Not overwhelming the model, but also not starving it of visual information. Kind of a Goldilocks zone.
Okay. And how do they actually construct the data for training? Any clever tricks there?
Definitely. For video, they didn't just caption the whole clip, they generated textual descriptions of visual changes between consecutive frames. These interframe captions really capture the dynamics, what's actually happening moment to moment.
Focusing on the change. Smart.
Yeah. And for web data, they use a caption-first strategy. Before showing the model an image, they generated a concise description for it. This provides a localized cue, helps the model know what to focus on, and reduces ambiguity.
Kind of like priming the model.
Sort of, yeah.
Yeah.
And if there was a lot of text between images, they used an LLM to summarize it, keeping things focused.
Yeah.
Then there's the reasoning augmented data.
Reasoning augmented. What's that?
Inspired by models like DeepSeek R1, they enrich the data with chain-of-thought style content. This involved manually creating tricky text-to-image prompts that require reasoning, generating examples of complex free-form image edits from existing data, and even conceptual edits like turning a photo of an object into a design sketch of it.
So teaching the model how to think through multimodal problems.
Exactly. Embedding the reasoning process into the training data itself. It helps bridge understanding and generation.
Okay, that's the data. What about the model architecture? How did they build Bagel to handle all this complexity?
They wanted to maximize the model's capacity, but avoid heuristic bottlenecks. Sometimes when you try to jam different data types into one model or use separate components like diffusion models, you create artificial limits.
Right.
So they went with a mixture of transformer experts architecture, MOT.
MOT. How does that work?
Instead of one giant transformer trying to do everything, MOT uses 2 specialized transformer experts. One focuses on understanding the input, the other focuses on generating the output.
Division of labor.
Kind of, but crucially, both experts operate on the same sequence of tokens and communicate through shared self-attention layers. This allows for deep interaction between understanding and generation without bottlenecks. It scales better because each expert can optimize for its task.
And what's the foundation, the core model?
The language processing part, the backbone, is inherited from the Qwen 2.5 LLM. That's a strong base for handling the text. For visuals, understanding uses a vision transformer encoder, specifically SIGLIP2, which is state-of-the-art. And for generating images, they use a pre-trained V8E, a variational autoencoder from a model called FLUX. Think of it as a powerful image decoder.
Okay, here's where it gets really interesting. This mixture of transformers approach. By having separate experts for understanding and generation, but letting them talk to each other, that sounds like it solves a huge challenge.
It does seem to.
It avoids that tricky problem where you're trying to optimize one set of parameters to be good at 2 potentially conflicting tasks, right? Understanding versus creating.
Exactly. It mitigates those optimization conflicts. It's quite an elegant architectural choice, really.
So we've got this incredible data, this clever architecture. What does it all add up to? The paper talks about emerging properties when they scaled Bagel up. What do they actually see happening?
Right, emerging properties.
Yeah.
In AI, this means abilities that don't just get gradually better with scale, but seem to suddenly appear at later stages of training. Like a switch flips.
A phase transition, kind of?
Yeah, exactly.
Yep.
Not just more of the same, but something qualitatively new. And they observed this clearly with Bagel. Their scaling experiments, which are really fascinating, show different skills emerging on different timelines.
Okay, like what?
Well, basic stuff like understanding multimodal inputs and generating high-quality images, that came relatively early, around 0.18 and 0.68 trillion tokens, respectively.
Still a lot of tokens, but early in their process.
Right. But here's the kicker. complex editing, the really free-form visual manipulation, that surfaced later. And most significantly, long context reasoning, the ability to really understand and generate based on complex, extended multimodal inputs that appeared last.
How last?
It needed a whopping 3.61 trillion tokens to hit 85% performance on a tough task they call intelligent edit.
Wow. 3.6 trillion tokens.
Yeah. This really shows, as they put it, how previously independent atomic skills synergize into compositional reasoning. The model learns the parts, then much later learns how to put them together in sophisticated ways.
So the ability to truly compose and reason across modalities isn't just a scaled-up version of simpler skills.
It seems not. It seems like a distinct emergent capability that requires massive scale and the right kind of data. It's like a separate developmental stage for the AI.
That has huge implications for training future models.
Absolutely. And they showed how critical the understanding part is. If they removed the visual understanding tokens from the VIT, performance on that intelligent edit task dropped by 16%, even though it barely affected simpler editing. Understanding underpins complex reasoning.
That finding about long context reasoning coming last is, well, it's pretty surprising, isn't it?
It is a bit counterintuitive.
It feels like the model learns its letters, then words, then basic sentences. And only after reading the entire library does it suddenly learn how to write complex, nuanced poetry. Is that a fair way to think about
That's
it?
a decent analogy, yeah. It's not just linear improvement, it's a jump in capability.
Let's make it concrete. What are some examples from the paper that really show these emerging abilities?
Okay, so text-to-image generation. Bagel can handle really complex compositional ideas, like a car made of small cars. Not just a car near small cars, but made of them. Or, he is surrounded by the national flower of the country that invented sushi. Bagel figures out sushi means Japan, national flower means cherry blossoms, and puts them around the statue. That requires connecting different pieces of knowledge.
That's impressive reasoning.
They also showed how rendering text, like the words "Hello Bagel" in an image, got much clearer and more accurate as training progressed, showing a deeper grasp of visual language details.
Okay, what about editing, the manipulation examples?
Some really cool ones there. Transforming a photo of a cake into what looks like crumpled aluminum foil, or the example of putting a lion hat onto a cat, and it looks totally natural, seamlessly integrated.
Right, I saw that one.
They also did conceptual edits, like taking a child's quirky drawing of an octopussy and rendering it as a realistic glass sculpture based on the drawing.
Whoa.
And maybe most striking are the world navigation and 3D examples, showing movement through a Minecraft world or an underwater scene, predicting future video frames. These imply the model understands space and physics, not just static images.
And this improved drastically at higher token counts.
Yes, Figure 9 in the paper shows this really well for intelligent editing. At earlier stages, for a complex edit request, the model might just reproduce the input image with tiny changes. But after 3.5 trillion tokens, it starts making coherent, semantically meaningful edits that clearly follow the instruction. That reasoning ability really kicks in.
Okay, so it's clearly got these advanced skills. How does Bagel actually measure up against other models on standard tests, the benchmarks?
It does extremely well, especially for an open source model. On multimodal understanding benchmarks like MMMU and MMVet, the 7B MOTI version of Bagel significantly beats other open source unified models like Janus Pro by like 14 and 17 points respectively. That's a big jump.
So it understands multimodal context better.
Yeah, and it's even competitive with models built just for understanding. Then for text-to-image generation using the Generative benchmark, Bagel hits an 88% overall score if you use an LLM to rewrite the prompt first.
88%? How does that compare?
That beats specialized image generators like FLUX1 Dev at 82% and SD3 Medium at 74%, and other unified models like Janus Pro, 80%. Even without the prompt rewriting, Bagel gets 82%, which is still top tier.
Very strong performance. What about reasoning and world knowledge?
On a WISE benchmark for world knowledge reasoning, Bagel, with self-chain of thought, gets a score of 0.70. That's way ahead of other open source models like Metaquery XL at a 0.55.
But still behind GPT-4o.
Yes, GPT-4 is still leader there at 0.80, but Bagel is closing the gap significantly for open source. And on image editing, using GetItBench, it's strong again, beating Step 1x Edit and competitive with private models. Interestingly, they note it tends to avoid making unintended changes elsewhere in the image, which even GPT-4o sometimes does.
That suggests better control. And what about that chain of thought, the thinking mode? Did that help?
Massively. Using COT boosted the wise reasoning score by 0.18 points, and for intelligent editing, the score jumped from about 45 to over 55. So explicitly prompting the model to reason step by step really unlocks better performance.
And the world modeling stuff? Navigation.
They show it's robust there too. Navigation, rotation, predicting multiple future frames, and it generalizes well. Even though it was mainly trained on real-world street navigation, it could handle navigating in, say, ink painting styles or video game environments.
That's an impressive leap, especially avoiding those unintended edits. And you mentioned they even showed a smaller 1.5 billion parameter Bagel could outperform larger models qualitatively.
Yeah, qualitatively, they showed the 1.5B version could sometimes produce better results than larger models like Janus Pro 7B or Step 1X Edit 12B on certain tasks.
That hints that this architecture and data strategy might be really efficient. Maybe efficiency is another emergent property here.
That's an interesting thought. It certainly suggests there's huge potential still untapped just by scaling this approach further.
Of course, no model is perfect. What are the limitations? Where does Bagel still struggle?
Right, they acknowledge failure cases. Things like generating specific copyrighted characters or styles special IP. Also, really complex text rendering within images, generating intricate human poses accurately, swapping objects between locations convincingly, or modifying many objects simultaneously. These are still hard.
Common challenges for image models, then.
Pretty much.
Right.
And they note that GPT-4o generally handles these edge cases most consistently right now. But the researchers are hopeful. They think scaling the data further, especially with more text-rich images, increasing model size, or using RLHF reinforcement. Learning from human feedback could address many of these limitations in the future.
Okay, so we've really dug into Bagel today. It feels like a landmark model, pushing the boundaries for open-source unified multimodal AI. It seems clear that scaling with this diverse interleaved data, plus smart architectural choices like MOT, is the key to unlocking these really impressive emerging capabilities.
Absolutely. It's a major contribution to the open source world. It gives researchers a powerful new tool, and just as importantly, deep insights into how these complex AI abilities actually develop. It really does, as they say, facilitate further opportunities for multimodal research.
So, wrapping up, what does this mean for you, the listener? Think about it for a moment. If AI models can learn to genuinely reason and create across images, video, text, and maybe more with this kind of depth, if they can even think through problems using chain of thought, what kind of completely new ways might we collaborate with AI? What new applications could become possible maybe sooner than we think?
Yeah, it's not just about slightly better image generation anymore.
No, it feels like we're seeing the emergence of a more grounded, more creative form of intelligence. Definitely something to mull over until our next deep dive.